Alright guys, section 7 is determinants and Cramer's rule. So we're just going to do a little bit of this today and we'll finish it up later. Determinants in a matrix is used for several things. Can be used to help calculate the inverse of a matrix, but the determinant on its own should be used to determine if a matrix has an inverse or not. You could also use it to find the area of a triangle if you know the vertices in a coordinate plane. So there's lots of uses besides that, but there's just a few for you. So evaluate determinants of the matrix. So we're going to start off with a 2 by 2. You can only take a determinant of an n by n matrix, like a 2 by 2 or a 5 by 5. Has to be a square matrix, we call it. So here's what we do with that. What you do is you take, actually I'm going to use a highlighter here. You take this diagonal and this diagonal. So you circle these two things. This is the downward diagonal. This is the upward diagonal because this has a positive slope, this has a negative slope. So basically, to find determinants, determinant is the downward minus the upward equals your determinant. Okay? So your downward minus your upward. So how much is your downward worth? Okay? How do you do that? Well, there's a 5 and a 1 in this downward. What you do is you multiply those things together. This is like, we'll say this is A, B, C, D. Why is that doing that? So this is A, B, C, D. You take AD minus CB. So your downward is made up of A and D. So AD, A times D, minus BC is equal to your determinant. Okay? So AD is 5 times 1 minus BC, which is 3 times 4, which is 5 minus 12, which equals your determinant, which is 5 minus 12 is negative 7. Negative 7 is your determinant. So those actually are pretty easy. If you do a 2 by 2 matrix, those are very easy. Remember that. But remember this, the downward minus the downward, we should say the downward diagonal. Alright. Ooh, can't spell diagonal. Diagonal. Upward diagonal. Okay? Downward diagonal minus the upward diagonal. And we're just multiplying here. Okay? So, we're going to try a different one, but it's a 3 by 3.